Hello dear viewers, welcome back again. Today in this session we will discuss chemical classification of diuretics. What are the different drugs which comes under this class? We will see the structure of those drugs in this session. Before discussing the chemical classification, first we should know what is the meaning of diuretics. So diuretics are the drugs or agents which increases the formation of urine in our body, and thus they are used in the treatment and management of heart related problems like high blood pressure or congestive heart failure. Basically, diuretics are broadly classified into two classes. First one is your mercurials and second one is your non-mercurials. These mercurials are those diuretics which have mercury atom in its structure. So all the drugs which contain mercury are classified under mercurials, and those drugs which do not have mercury in their structure are classified as non-mercurials. But you have to remember this, that mercurials are not used nowadays as a diuretic because they causes toxicity due to mercury which is present in their structure. But for the sake of our knowledge, we can memorize that previously mercurials like chlormeridron or mercalil, and there are several other mercury compounds which are used as a diuretics. But nowadays there are safer and less toxic diuretics are available like thiazide diuretics and your loop diuretics and your carbonic anhydrous inhibitors. So nowadays we totally used non-mercurial diuretics in the treatment and management of heart related problems. So let's begin our discussion. First we will see the structure of mercurials. So first we will discuss the drugs which comes under mercurials. So your mercurials as a diuretics. So the general structure of drugs which comes under this class is R C double bond O NH CH2 CH then CH2, then here comes your Hg, and on Hg you have X, and here you have OR1. So basically there are 3 points where changes takes place. So first, this is the general structure of your mercurials. So first we will see the structure of chloromerodrin. So where are the changes in chloromerodrin? So here in place of X there is a chlorine atom, and at R1 it has CH3, and at your this R functionality it has amine moiety. So this is the structure of chloromerodrin. Now we will see the structure of mercalil. So mercalil have following changes. In place of chlorine it has hydroxyl group. The CH3 remains as such, but here in place of amine these have benzene nucleus, and on this benzene at this ortho position they have OCH2 COO Na. So this is the structure of your mercalil. Now let's move on to the non-mercurials. Now the first class in non-mercurials is your thiazides. Thiazides is chemically also known by the name benzothiadiazine, thiadiazine derivative. Benzothiadiazine derivative. So first we will see the general structure of thiazides diuretic. So as its name indicate, benzothiadiazine, so somehow they have a benzene nucleus. So this is your benzene, then thiadiazine. So thiadiazine means a sulfur containing ring which have 2 nitrogen in its structure. So this is your thia, this is first aza, then this is your second aza. So benzothiadiazine. But the structure of general structure of benzothiadiazine is represented like this. Here double bond is there, here NH group is there, and on this sulfur is connected with 2 oxy group, and at this position they have sulfamoyl group, NH2 SO2, sulfamoyl group, and at R1 and here R2 they also have this functionality. Now first we will see the numbering of this general structure or thiazides. So numbering begins from sulfur, 1 2 3, then 4, then 5, then 6, then 7, 8. Likewise the numbering is there. So this is the general structure of your thiazides or benzothiadiazine derivative. Now we will see the structure of some important drugs which comes under this class. First drug is your chlorothiazide. Now where are the changes in chlorothiazide? So you have to remember this. In chlorothiazides there is nothing at this R3 position, but at R2 this drug have chlorine functionality. So this is the structure of your chlorothiazide. Now there is another drug, flumethiazide. So where are the changes? So as in the name, flu and meth means fluorine and methyl. So there is again here at this position there is trifluoromethane group is there. So this is the structure of your flumethiazide. Now another class, second class number 2, hydrothiazides. There are 3 substituents on this ring, benzothiadiazine ring. First R1 group is there, and it is a hydrothiazide. So there is addition of hydrogen at this position, so no double bond is there, saturation of this bond is there. So again this nitrogen acquire hydrogen, and at this position there is another functional group R2, here R3, and sulfamoyl groups remains as such. So this is the general structure of hydrothiazide. Now some important drugs which included under this class is hydrochlorothiazide. So hydrochlorothiazides have at R1 and R2 position they have hydrogen, and here again chlorine is there. So this is the structure of hydrochlorothiazide. Now there is another important drug, hydroflumethiazide. So again flu means fluorine, and me means methyl. So hydroflumethiazide. So again both hydrogen remains as such, but in this position there is again CF3. So this is the structure of your hydroflumethiazide. Now class number 3rd, this is called carbonic anhydrase inhibitor. Chemically, this class is also known by the name thiadiazole derivative. The important drugs which comes under this class have thiadiazole ring. What? Thiadiazole ring in its structure. And example of drugs which comes under this class is your acetazolamide. Acetazolamide have thiadiazole ring. So first we will draw the thia, this is sulfur, in one aza, mono aza, and this is your second aza. So thiadiazole. So this is your thiadiazole, and acetazolamide, as the name indicates, it has acetamido group. Aceta means acetamido group. So this is your NHCOCH3. This is acetamido group, and here at this position they have sulfamoyl groups, NH2SO2. This is the structure of acetazolamide. Now second drug which comes under this class is methazolamide. Now as the name indicate, this has meth means methyl group is there. So where this methyl group is, so actually what happened here in this drug, this double bond is saturated here, and on this nitrogen there is methyl group, and this single bond becomes double bond. By removing this hydrogen, this bond becomes double bond. So this is the structure of your methazolamide. Now there is another drug which comes under carbonic anhydrase inhibitor, but this drug do not have thiadiazole ring in its structure. Name of the drug is dichlorofenamide. So what is the structure of dichlorofenamide? As the name indicates, dichloro means 2 chloro and fen means phenyl ring is there. So this is your phenyl ring, and dichloro means this is first chloro and this is second chloro. Dichloro, and phenamide means at this position it has SO2 NH2, and at this position it SO2 NH2. So this is the structure of dichlorofenamide. Now class number 4, sulfamoyl benzoic acid derivative. Most of the drugs which comes under this class are also known by the name loop diuretics. So the best example of loop diuretics is your furosemide. So furosemide is the drug of class sulfamoyl benzoic acid derivative. So first we will draw the structure of sulfamoyl benzoic acid. So this is your benzoic acid, and at the meta position this drug have sulfamoyl moiety. This is your NH2SO2 sulfamoyl moiety. So this is the basic structure of sulfamoyl benzoic acid. Now furosemide, as the name indicates, furo means furon ring is there. So this furon nucleus is attached here, NHCH2, and here is your furon ring, and at the para position this furosemide also have chlorine. So these are the two structure you have to memorize for the structure of furosemide. Now there is another drug, bumetanide. Bumetanide. So bumetanide also have same sulfamoyl benzoic acid structure, sulfamoyl benzoic acid derivative. So this is the general structure, but as the name indicate, bu means butyl species or 4-member carbon structure is there. So where this 4-member carbon structure is, so here is your amine group NH, and on this amine group here is your CH2, CH3. So this is your butyl, and at this position this drug have this phenoxy nucleus, phenoxy. So this is the structure of bumetanide. Class number 5th is your phenoxy acetic acid derivative. So first draw the structure of phenoxy acetic acid. So this is your phenyl ring, this is your phenoxy, and acetic acid means here is your acetic acid group CH2COH. This is phenoxy acetic acid nucleus. Now the drug or example of drugs which comes under this class is your ethacrynic acid. So in the name of this drug, eth means somehow ethyl functionality is there, and acry means acrylic functionality is also there. So what is acryloyl group? So acryloyl group have following structure: R, C double bond O, then CH, then double bond CH2. So this is your acryloyl group. So this drug also have, ethacrynic acid also have ethyl and acryloyl functionality. So first we will draw the acryloyl group. So here is your acryloyl group, C double bond O, then C double bond CH2, and on this carbon this drug have your ethyl acryloyl. So ethyl and acryloyl, but this ethacrynic acid also have 2 chlorine at this position. So this is the structure, complete structure of your ethacrynic acid. Class number 6 is purine or xanthine derivative. Purine or xanthine derivative. So this is the basic skeleton of purine, and if we remove this 2 double bond from this ring and attach here carbonyl group, here also carbonyl group, and this N become NH and this N become NH, then this becomes your xanthine nucleus. This is your xanthine nucleus. Now we will see the example of drugs which comes under this class. So first example is your caffeine, and caffeine has following structure. At both the nitrogen of this 6-member ring, methyl group is there, and on this pentacyclic ring this nitrogen have methyl ring. So this is the structure of caffeine. Now there is another drug, theophylline. So theophylline have what changes? So in theophylline only this methyl group is removed from this position, and whole structure remains same. This is the structure of your theophylline. Now we will move on to the next class. Class number 7, sulfonamide derivative. So the best example of drugs which comes under this class is chlorthalidone. Chlorthalidone has following structure. This is benzene, this is chlorine, and this is your NH2SO2 sulfamoyl group, and this ring is directly linked to a pentacyclic nitrogen containing nucleus which have carbonyl group, and this ring is fused with your benzene nucleus, and at this position they also have one hydroxyl group. So this is the structure of chlorthalidone. So why chlorthalidone? So chlorine is there, and on means ketone, so this is your ketone functionality, and this is a sulfonamide derivative. So sulfonamide have basically sulfamoyl and benzene nucleus, so this is that's why it is called sulfonamide derivative. Class number 8, pteridine derivative. Pteridine derivative. So what is the structure of pteridine nucleus? So pteridine has this nucleus. This is your pyrazine nucleus, and this is your pyrimidine nucleus. So pyrazine and pyrimidine, when both this nucleus fuse with each other, then the structures obtained is called pteridine. So example of drugs which comes under this class is triamterene. Triamterene has what functional group? So tri and M. Tri means 3 and M means amine. So triamine. So these are the triamine. First amine, second amine, and your third amine, triamterene. But this drug also have at this position phenyl nucleus, C6H5. So this is the structure of triamterene. Class number 9, pyrazine derivative. Pyrazine derivative. So pyrazine is nothing but this structure is known by the name pyrazine. So the drugs which comes under this class is amyloride. So amyloride had what functionality? So again M for amine. So here are the amine, NH2 and NH2, two amines. Low means clo. So here is your chlorine. And ide means guanide. So this position is linked with NH, double bond NH, NH2. So this is the structure of amyloride. Now class number 10, aldosterone inhibitor. Aldosterone inhibitors, or this is also known by the name potassium sparing diuretics. And the best example in this category is your spironolactone. Spiro means this compound have spiro functional or spiro junction, spironolactone. So what is the structure of spironolactone? So this is the structure of your spironolactone. Spironolactone. On means two ketone, first one and your second one, and spiro means this junction is known by the name spiro junction. So spironolactone. Class number 11, osmotic diuretic. Osmotic diuretics. So osmotic diuretics have best example is your urea, and urea has NH2 C double bond O NH2. This is the structure of urea. And second one, the best drugs which comes under this class is your mannitol. Mannitol. So this is the structure of your mannitol. CH2 OH, then CH, then CH, then COH, then COH, then CH2OH. Now here H, then OH and OH. So this is the structure of your mannitol, class number 11. Now there is again last class, class number 12, acidotic diuretic, and it includes the best example is your NH4Cl, ammonium chloride. So in this way, this completes your chemical classification of all the diuretics. I hope you understand the example.